Oh, en heb jij je memory recorder weer bij?
Ja.
Kan daar het eerste beginnen?
Uiteraard.
Super, oké, want de kwaliteit van deze afstand is net niet helemaal goed. Even denken. Oh nee, laten we eerst nog even één ding bespreken. Heeft iemand het artikel gelezen? Pragmatic Software Development? Ook een hele leuke over startups. Daar komt het eigenlijk vandaan, het artikel. We hebben dat geschreven met 2 studenten. En het gaat specifiek over hoe je heel snel zo'n componenten met elkaar kan raken en daar een product van kan bouwen. Wat wel jammer is dat allebei die producten die ik daar gepresenteerd heb, zijn gefaald. Dus allebei die producten die in het artikel beschreven worden, die zijn niet gekomen waar we hoopten dat ze kwamen. En we schrijven er juist van ja, dat een beetje cut en paste, zo bij elkaar gooien en iets moois ervan bouwen. Dat een hele snelle en slimme methode is om te bouwen. Dus het is jammer dat het 2 gefaalde business cases zijn. Maar nee, het zit niet altijd mee. Wat ook wel belangrijk is, en dat ga ik later denk ik ook nog een keer laten zien, dat figuur met die een soort architectuurplaat met 8 verschillende mogelijkheden waarop je 2 producten met elkaar of 2 componenten met elkaar kan verbinden. En later zal ik ook nog uitleggen waarom dat handig is om daar een bepaalde methode voor te kiezen. Het heeft vooral met licenties te maken. Daar gaan we het later nog over hebben. Nou, we spreken het vorige keer, hebben we het over gehad. Allemaal duidelijk. En nog vragen over het software product management verhaal? Meestal zou ik eigenlijk nu weer eerst de theorie over gegeven hebben en daarna de praktijk. Maar de theorie komt dus nog. Ik denk dat hij wel verteld heeft over verschillende releases van Ultimo, requirements. Ja? Kijk, mooi. Alright. Well, this is, nu ga ik gelijk over het Engels spreken. So this is the figure where I'd like to start. I think I've showed it before. And like I said before, this is sort of the development cycle of product software. It's becoming a bit of a benchmark or standard picture. And as you can see, customer on one side, software vendor on the other side. Software vendor is developing a software product, then releasing it, then it's being deployed, implemented at the customer, then it's being used, feedback comes from that, and then hopefully this continues. So this is true for one project, but it's more so for a product because, well, the more feedback the more customers you have, the more feedback you can gather, and the more you can increase in general in your product. So that's the general gist. There's some policies around it which we can discuss later. Let's see if I can.
Nope.
Okay, we're unlucky. So let's start with a quick question. What are the main differences now as you've gathered between project and product software? Can somebody give me,
Yeah, a project is usually focused on one customer.
Yeah,
and
one customer.
Product is, or it can be multiple customers or all customers.
Yeah. Okay, good. One of the best ones, I think. Any other ideas? The next slide will be an overview of 8 differences. So we now have one. Yes?
More of a one-time effort.
Yeah. Yeah. Sure. Yeah. Anything that's specific about a product and a project? What do you think about the architecture, for instance? Is the architecture, is it more important for a project or for a product? Any idea? Why would it be more important for a product?
Because it's like more generic, because it's for more customers, so projects will focus more on consultancy or implementation.
Yeah. Yeah, and for a project it's true that if it works, it works. So it doesn't matter how it works as long as they talk to each other, the services talk to each other in the right way and it performs quick enough, then quite soon you can say, well, good is good enough. But for a product, you have to be generic, it has to be easy to install. You may have to make use of a third-party database, so you start thinking a lot more like, okay, this is one particular product that has to function in different environments, and therefore the architecture has to be pretty stable. Another reason for the architecture having to be pretty stable is that year after year you're improving on the product, and by doing that you may have to let go of some of the ideas that were in your earlier architecture. One of the concepts that's important here is architectural erosion. So we talk about architectural erosion when you sort of not control the architecture over subsequent releases and you just leave it be, and then at some point one developer will say, I'm going to break through this convention, and well, I'll give you some examples of it later, but not today, because today we have some other things to discuss. So here you see a nice comparative table. Obviously, if you learn this one by heart, you'll have a nice grade on the exam for this question. So we talked about the architecture plays a strong part. Variability, of course, if you're building a one-off, there is no variability because you can't, there's nothing to vary. But if you're deploying for multiple customers, well, then you need, some people want a blue car, other ones want a red car. So you need it to be variable. Many releases, long lifetime, and many different developers throughout the life, which of course is different with a project. So with a project, it's, deadline and investment play a strong part. You can imagine if a bank pays Capgemini to build a new banking system, then that's going to take a big effort and a lot of money up front. And as long as the right milestones are met, Capgemini is happy. Whereas here you're much more thinking about a business model. How am I going to sell my product over and over again and keep making money? Some parts people never touch again, so you can imagine a project will be, take an example, if I build a website for an uncle of mine, then a large part of that website I'll never touch again. Of course, maybe at some point I'll add, a Twitter feed or something like that, but nothing big. Whereas for a product, you could say, well, for the next version, we're going to do a whole revamping of the architecture, or we're going to add another component or another possibility, or a mobile version, or things like that. Few releases, many developers on the first release, and after that, mostly maintenance. So what you typically see, I'm currently doing a study at Rabobank, and Rabobank has a very big system in what you call COBOL code. It's running on IBM mainframe. It was created in maybe the 80s, early 80s, late 80s around about. And since then it has been transferred to India, and in India they've worked on it for about 10 years, and they were no longer happy with their supplier there, so it went to Cognizant, another company, a worldwide company, and now they're sending it back to India again. But that's all maintenance. So for the very first release there were maybe 100 developers working on it at the same time, but then after that it was usually 1, 2, 3 developers, and then moving from company to company. So the knowledge was also quite well easily transferable. Obviously you need to have the right knowledge about this. Now, if you find this kind of thing, what I want to say here is that this kind of software is making the world run to a certain extent. So as soon as one of you is going to work at a bank or work at an insurance company, or you will see these large systems, and you maybe will have to make decisions about these systems. One of the decisions Rabobank is now making: how can we move from this old COBOL code to more Java-oriented or object-oriented or service-oriented software. That's really a good move, I think, but really hard for them to transfer the knowledge from these age-old systems, which have been improved over time and work pretty much perfectly, but a little bit too slow and not modern enough and can't change with the enterprise. So these are decisions that you two will be making in the future, so keep that in mind. Alright, so, and you can see there's many more differences you need to think about. What I miss here a little bit on the left side is the business model. So your business model there is a huge factuurtje or a one-time price offering, whereas here it's, you vary with your prices, you sell it as a bundle, you have variability, so that's... So here's a nice example. This is my sort of dream car, but unfortunately I'm in the wrong profession for this car. And here you can see that, okay, you could buy, so this is a typical product, and interestingly enough, I think software is very related to cars in the way in which they're built, and the way in which they're designed, developed, and also in the way in which they offer variability in a very easy way. So here you can, for instance, say, okay, I want this color for car, I want this color leather, I want these kinds of wheels, and I think later on I'll give you a very nice overview of how variability works in software products. So you can also imagine hybrids. By hybrid I mean a company that does both project and product software. And the idea behind that is, of course, that, let's take an example of this. So these are companies that may be somewhere in the middle stage. So somewhere between, are we a project or are we a product company? You can imagine if you're building CMSs, content management systems. Let's say you're implementing Drupal. So Drupal is a content management system, and you've built a nice CRM component for Drupal. Then you start selling it, and you sell it to one customer, and then you sell another Drupal installation to another customer, and to another customer, to another customer. And at some point, a fifth or sixth or seventh customer comes by and says, hey, you have a CRM component? That's interesting. We would like to have that. well then you're obviously being a bit of a hybrid company because you've sold your own software to multiple companies, but you're also reselling Drupal software. Of course, Drupal is open source, so it's not really reselling. So you can imagine that there's hybrids possible, and one sort of typical development that comes out of this is software product lines. So let's see if I have a nice picture of that. Yeah, here we go. Maybe it's easier to just explain it quickly before I show this picture, because I find this a little bit complex at times. Pretty much, if you're a product line oriented company, what you have is a bunch of components. So maybe these three guys are working on a GPS software component, these three guys are working on a maps component, you three guys are working on a locations component. So if I put all three of you together, then I could easily have Google Maps as a product and deliver that to different customers. But if I only put you two guys together, then I have a navigation product. So then you can deliver different products. So here you see there's different products coming out. And I think this picture would be better if these were different shaped. So circle, square, circle, triangle, triangle. And then you can see that, you know, some things you sell maybe once or twice and others you sell 100 times. And depending on, well, that's what makes a software product line company. Well, what's important here? So I talked about these core assets. Also, yeah, production plan. So how are you going to configure and make sure that all these components work together? And very interesting here is that, so you have to start planning a little bit differently. With the product, you just say, okay, I have one product, I sell it 100 times a year, so this is my business planning. On that product, I will have 10 developers working full-time, and that's sort of your simple business plan. Here you have to go a lot further than that. Some components you may have to work on once with 5 developers, and then sell it about 1 million times. Whereas with others, you might say like, okay, you have to really make the trade-off. Okay, well, this customer wants this particular component. If we work on it with 20 people, we can deliver it in time, but only for half the price. How large is the chance that we will sell it again? So those kinds of considerations then are accurate. Very good. So, can anybody explain to me what a typical software development process looks like? I think I already sort of mentioned it at the beginning, but can somebody give me an idea of what it looks like by now? Pretty blonde girl in the back? Yes, you know. Me? No, you're also pretty, but I'm not. Okay, so let's say if I asked you to build a car, how would you start? Okay, what kind of product do you like? Do you have an iPhone? No. Okay, so how would you start with designing your phone?
I look at what the user wants.
Okay, requirements engineering, that's a good idea. Yeah, yeah. Yeah, okay, and then the second step? Let's say they're perfectly done and you have a document with some requirements, then what?
Prototype.
Okay, yeah, I like that. Why would you make a prototype? Why don't you just go for the real things?
Just to test it.
Great, you're smarter than you think. Alright, we'll get to that in a minute. You're way ahead of me. Alright, so I really like how she went about it, because she first wants to make a prototype, then release it maybe, then get some feedback, then keep on developing. Well, we'll get to that in a minute. Let me see what I'm trying to say here. So here I'm just trying to say how important software is. So, well, here you see some things that can happen when you have a bad product. So you can have, liabilities. What if your product says, puts all the traffic lights on green and everybody crashes? Increase or decrease productivity. So you can imagine a good SAP implementation can really increase productivity. A bad one will decrease it. Of course, if it gets too heady or too big of a project, it will also damage your business. Well, you can imagine really important points for software. Alright, so let's talk a little bit about the software development lifecycle. This is sort of the traditional view. I will give maybe 2 or 3 slides about the traditional view of developing software, and then we'll go into some of the more agile methodologies or methods that you mostly know about, I assume. So 7 phases. You start with planning, analysis, design, development, testing, implementation, and then maintenance. And then you can sort of keep going like this. And depending on the product, depending on the nature of your business, depending on you,
you determine how quickly you want to move through this. So for instance, for Scrum, the most agile way of working and the most typical way, I think Erik Huisman must have told you about it as well. You have these cycles for maybe 30 days or 4 weeks. If you're developing a Mars Curiosity rover, then this process will take a year, 5 years, 7 years. Well, depending on the, but of course the most important part about doing this quickly is that you can work in increments. And increments has the advantage that you can constantly test, like, okay, where are we going in the right direction? Well, we'll get to that in a minute. Let's first talk a little bit about this traditional model. So, blonde girl in the back, what's your Kirsten? All right, so Kirsten, she already came with requirements engineering. So that's a little bit of, well, I'd say more analysis. So I personally would start, and this is because the one thing you guys don't realize yet with your young age is that money makes the world go round. And that's something that you never have to forget, that whenever you want to start building software, the first thing you have to think is, how am I going to pay the developers working for this? Or if it's open source, how am I going to get people on board to work on this? So that's the planning phase. Well, analysis is then requirements engineering, seeing, okay, are we doing the right thing? Maybe even sketching out your architecture. Then the design, so then actually making the architecture and seeing where that's going. Doing the actual development. Then some testing, implementation, and maintenance. Implementation is, of course, putting it into practice, and maintenance is making sure it keeps running, no bugs occur, those kind of things. Now, this is really important to get this. Again, this might also be an exam question. The exam for this course has a typical nature of being a bit of a study exam. I'm trying to make the questions more intelligent, but somehow I lack the brain for that. So, but this could be a typical question. What are the 7 phases of the SDLC, the software development lifecycle? Yeah, I think we talked about these: design, development, implementation. Yes. So here you see some other typical methods. I was trained in the waterfall method, so that already tells you that I'm getting quite old. Of course, the agile methods were around by then. I was studying software engineering in 2001, 2002, so that's when we heard most about this. But of course, agile was then sort of the hot topic, and so let's first talk about, well, we're going to talk about each of these. I think we will first go into waterfall. So waterfall was sort of this traditional view of, okay, you're the tech services and you need a big system. And if you need a big system, you need to think about it for a long time, have committees the size of this room, sit together and discuss, are we doing it right, are we going the right way? And of course back then also the credo was, software is always late. So, which makes sense, if you get a group of us in one room and we all try to build one big system, then that can take a lot of time and a lot of consensus making and etc. But this is sort of the way we thought about it, and then of course, well, here you see those phases again. And the idea was that you weren't allowed to go back, but you were only allowed to close a phase when everybody was happy about a phase. And again, that's one of those, you know, of course, planning and analysis, for instance, could take much, much longer than expected. Because of course you can say beforehand, well, it will take 3 weeks to get all the requirements. But how do you know? I mean, you don't even know what the requirements are yet. So how